All right, my name's Matt Fuller. I work at Teradata on a project called Presto. So today I'm going to speak about Presto and the connectors and extensibility of Presto. So for those who don't know, what is Presto? It's an open source distributed query engine. It was designed from the ground up with interactive analytical queries in mind. It even scales to the sizes needed by companies like Facebook. And the neat thing about Presto is it queries data where it lives. So you could have your data in a variety of data sources, which I'll talk about, and you can query data there without having to pull it into a system like Presto. It's Hadoop distro agnostic, which means you can run on MapR, Hortonworks, Cloudera, even on EMR. A lot of people are using on EMR. And it's extensible. I'll talk about that in a little bit. And it's used by a lot of well-known companies in industry. Facebook, being the largest one. In fact, they're the ones that originally developed it to suit their needs at Facebook. They have clusters totaling thousands of nodes. They even use it on their 300 petabyte Hadoop cluster. So they use this extensively there, and they're some main contributors as well. So what is Presto? Presto is performance. Some of the things are obvious. It can horizontally scale out. We process in column or vectorized manner. There's optimized readers, such as for ORC or Parquet data or so on. And it's also written in highly tuned Java. So we've been very careful about efficient in-memory data structures, very careful coding of inner loops where it matters, and even Java bytecode generation. So here's the basic architecture. You'll see that it's basically a single coordinator and one or more workers. The more workers, the more parallelism you're going to get. So you see on the coordinator, query comes in, gets planned. The workers do the data processing and returns the results. And I'll talk about the extensibility here. So if we look back at this slide, you'll see that there are various APIs, Metadata API, Data Location API, and Data Stream API. If you want to write a connector, you implement those basic APIs, so you can query data from Hadoop, Hive, Cassandra, Kafka, MySQL, Redis, Mongo. These are all connectors that exist out there, Accumulo. And the really cool part is you just issue SQL, standard SQL to Presto, and the connectors take care of the underlying data source. The other cool thing is the single query can combine data from multiple data sources. So if you want to join data in Hadoop and data in one of your relational databases, you can. So what we've done at Teradata is we've put it into what is known as Teradata Query Grid, which is, I can speak on this a little bit more, but it's basically you can be in any of the Teradata products like Teradata or Presto, and you can query each one. So you can be in Presto, query Teradata, you can be in Teradata, query Presto, and you can even move data back and forth if you want. So one of the more advanced implementations of a connector in Presto is doing it in a more scalable and parallel way. So unlike your basic connector where you're issuing a query to Presto, it goes to the data source and returns the data back in a singular fashion. You can actually have sort of a bidirectional, fully parallel exchange. So here we're streaming data from the amps to the Presto workers back and forth to get even more performance. So what is Teradata doing with Presto? So on our team, we're working on open source contributions to Presto to increase the adoption of enterprise in Presto. We have a multi-year roadmap to enhance the open source, and we actually offer a support offering for Presto. But we're providing ODBC and JDBC drivers for free to the community, and also driving business intelligence tool integration such as Tableau. So contributing, we're on GitHub. There's a Presto users group, IRC, Twitter, Facebook. You can go to PrestoDB.io to learn more and sign up for those. And the PrestoDB code is on this GitHub, and here's Teradata's GitHub here. And just wanted to leave with this, one of the interesting connectors I could see is someone writing it for scientific data. So I happen to be aware of these n-tuple root files that is used at CERN, and I thought it'd be cool if we could write a connector to query directly from scientific data such as that. It doesn't have to be that particular data. Instead of having to transform it and load it into a database and query it, you can query it directly using Presto. So that's an interesting idea for a connector.